So down in the check your understanding, we want to determine whether it is more expensive to live in California or Florida. So we are subtracting these two means. We're doing the sampling distribution of the difference of these two means. And the first thing I want to know is, what is the shape of the sampling distribution? Yes, sir. It's going to be approximately normal. Why? Yes, it tells us right up here that the monthly cost of living expenses for California are approximately normal. So one of my populations is approximately normal. And then here, second sentence, monthly cost of living expenses for Florida are approximately normal. Both of my population distributions are approximately normal. So the difference in means for those two, for my sampling distribution, will be approximately normal. What if they weren't approximately normal? Would I be able to say anything about the shape? No. What's the only way that I would be able to say something about the shape? If the populations aren't approximately normal, there's one other condition that I could look for that would allow me to say something about the shape. Central limit theorem, which means I need samples of at least how big? 30 or more. If I take a sample of 30 California residents, a sample of 30 Florida residents, then my central limit theorem would apply, and it does not matter if the population distribution is approximately normal, because the sampling distribution would be approximately normal. So either my population has to be approximately normal, or I have to be taking samples of size 30 or larger so that my central limit theorem applies. That would allow me to say that the shape is approximately normal for that difference. What if that didn't work for one of my two states here? Say that wasn't true for California. Could I say anything about the shape? No. In that case, I would say that the shape is not normal. I don't know whether it's skewed left, skewed right. I don't know whether it's symmetric. I don't have any idea about the shape, but I can say that the shape is not normal. And then I would go on to say why I would have to say it's not normal. Either the population's not normal and it's failing at the central limit theorem, or some other reasoning there. I would have to provide that justification. So far, so good? But in this case, we said it is what? Approximately normal. How do we find the mean for the difference? Yes. I subtract the mean for California from the mean for Florida. So I'm doing 10,800 minus 8,500, and we get what? 2,300, absolutely. How do I find the standard deviation? How do we find the standard deviation? Yes, sir. Yes. So sigma of x bar 1 minus x bar 2 is going to be equal to, and then I've got a big old square root here, sigma 1 squared over the square root of n1. Sorry, not square root of n1, over n1. Come on. I started to write n1 and then my hand made a square root sign instead. Plus sigma 2 squared over n2. What is sigma 1 here? In this case, that would be California, right? What is our standard deviation for California? 3,200. So I would have 3,200 squared over n1, 16, plus, and I need this all underneath a big square root sign here. What for my next piece? 2,700 squared over 9. And when you calculate that, you should get $1,204.16. For the third question on here, it said that we wanted to calculate the probability that the average monthly cost of living expenses of the 16 randomly selected California residents is less than the average monthly cost of living expense of the 9 randomly selected Florida residents. So basically, we're trying to figure out the probability that it is cheaper to live in California than it is to live in Florida. What would the difference between those two be if it cost the same to live in both places? 0. If it's cheaper to live in California than it is to live in Florida, what kind of a number would we be seeing? A positive or a negative when I do the subtraction here? Negative. I'd be seeing a negative. So I'm going to draw my normal distribution here. What do I put right in the center? 2,300. My standard deviation is how much? 1204.16. Don't forget to label this. That n is really important. It means that it is approximately normal, which we showed up above in Part A. That's why we're allowed to do Part C with a normal curve. 2,300, $1,204.16 for our standard deviation. Where would 0 be on here? Because you said it needs to be a negative, so I need 0 and less. Yep, so somewhere over here, right? And I heard negative 1.9. If we calculate our z-score, 0 minus 2,300 divided by 1,204.16. We get negative 1.91. That tells me how many standard deviations away I am from the mean. Tells me about where to put it on my picture too. We are trying to calculate the probability that x bar for California minus x bar for Florida is less than 0, is a negative number. So that's the same thing as the probability of our z-score being less than negative 1.91. We can look that up on table A. Let me write that down, actually. Or we can pop this into our calculator. Normal CDF. And then I always need to do lower bound, upper bound, mu and sigma. Is a good lower bound here 0? Why not? Yeah, we're looking for 0, and if I look at the way I drew my picture, that's my upper bound. So I need to pick something that's quite small. Negative 10,000 sounds good. My upper bound would be 0. Mu is 2,300, and sigma is 1204.16. So I know I talked about this some last semester, but I'm going to continue harping on it this semester just because from what I've seen, it is important when they go in and grade the AP Stats test. They want to make sure that you know what each of those pieces are that you're putting into your calculator. So if you are doing this right here, label, this is my lower bound, this is my upper bound, this is my sigma, this is my mu. Make sure you're labeling those pieces before you put them into your calculator so that you're not leaving that AP reader guessing about what these numbers are. You're telling them what the numbers are and you're showing that you understand. Plus, some calculators work differently. You can't just rely that if you put them in a particular order, the reader is going to know, oh, well, they're using a Casio calculator. That's why these two numbers are switched. If you label them, then it doesn't matter what kind of calculator you have, and you're not asking the reader to do any guesswork. Does that make sense? Okay. The other thing I want to make sure that we're doing each and every time on a calculate the probability for something that is normal is that you are drawing this You are labeling where you're shading at. So things that you have to have labeled, you have to have the mean labeled. You have to have your standard deviation labeled. You need to tell me that it's normal. You need to label where you're shading, and then you need to show me which direction you're shading. Those are the things that I'm looking for, because those are the things that we've gotten feedback on. That's like, this will be the difference between like a 3 and a 4 or a 2 and a 3 on a particular question. Pop that in your calculator, and we get about, what? 0.028, yes. Whether you look it up on table A or you pop that into the calculator. Yep. Nice work, guys. So about a 2.8% chance, or 2.8% probability that it is cheaper for an individual to live in California than in Florida. All right, I want to look now at the last piece of paper in your notes packet. It kind of summarizes a lot of the big things that we've talked about and gives us a chance to talk about sample proportions versus sample means. There are some similarities and differences. And all of the formulas that we have used are on this reference page that you guys get to use on the test. Not necessarily the one that we're going to write on right now, but the one that you get to use on the AP Stats test. It's absolutely there. Let me pull this up here. There we go. So if you have your reference sheet handy, go ahead and pull that out for me and look on the back of the front page. So this is where all those things are going to be labeled for you. And if anybody needs an extra copy, just let me know. Happy to pass one out. If I am talking about, sorry about that, guys. If I am talking about proportions, what letter am I going to see show up a lot? P. P and P hat. Which one is my parameter and which one is my statistic between P and P hat? Aiden. P is my parameter. P hat is my statistic. P is the true proportion. Let me rewrite that. So what is P hat then? We said it's our statistic. Where is it coming from? The sample. That's our sample proportion. How do I find the mean of the sampling distribution? How do I find the mean of the sampling distribution, or mu of P hat? It equals P. This is one of those things that is on your reference sheet. If you look on your reference page, I'm on the back of the front piece of paper here. It says sampling distribution for proportions for one population. Mean or mu of P hat equals P. I've got that right there. Standard deviation of the sampling proportion. How do I calculate that? First of all, what letter do I use for, or what symbol or letter do I use for standard deviation? Sigma. So I want the standard deviation of my sampling distribution. So sigma of P hat. Anytime we're doing standard deviation, what operation do I always see? Square root, big old square root here. What goes inside my square root? P times 1 minus P over N. P is a proportion. That is the probability of success. 1 minus P is the probability of failure. I only use that with proportions because that's when I have this binomial. Before we do the bottom part of this, because I want to kind of compare and contrast here, things that are the same, things that are different. This is if I have one sample. What about if I have 2 samples? What is my parameter if I have 2 samples? P1 minus P2. P1 minus P2. This is the true difference in proportions. So what would my statistic be? P hat 1 minus P hat 2. How would my interpretation of that change? Is that still the true difference in proportions? What is that then? Sample difference in proportions. How do I find the mean of the sampling distribution? Yes. So the mean of p hat 1 minus p hat 2 is equal to proportion 1, or proportion for population 1 minus the proportion for population 2. So I subtract my proportions. Do I subtract with my standard deviations? Do you ever subtract with standard deviations? No. Do you ever add standard deviations? Close. Do I add the standard deviation?
Oh, no.
No. What do I add? The variance. We add the variance. So sigma of p hat 1 minus p hat 2 is equal to, underneath my square root here, I have P1 times 1 minus P1 over N1 plus P2 times 1 minus P2 over N2. What condition must be met for me to use the standard deviation formula? 10% condition. What are we checking with the 10% condition? Yes. Why does that matter? Why does it matter if we take more than 10% out of our population? What would that change? Independence. We need to check for independence. We're not checking for normality with our 10% condition. We're checking for independence. So what condition must be met? The 10% condition. Important for independence. How do I check that? How do I check my 10% condition? Yep, sample size. Needs to be less than 1/10 the population. Little n is my sample size. Big N is my population size. And so I would want to write it down like this, but then I could check it by multiplying my sample size by 10 and saying, I know my population is at least that big or bigger. What about over here? What would have to be true? Same thing, but for both samples. 10% condition has to be met for both samples. And my samples have to be independent of each other. Yes. So while I realized we were looking at sample means just a second ago on the check your understanding, if I take a sample from California and a sample from Florida, those are going to be independent of each other because there's nobody who currently lives in Florida and could be part of my sample who is also a primary resident of California. You have to pick one state as your primary state of residence. So those would be independent. When is the sampling distribution approximately normal? Let's look over here for just one population. How do I know if it is approximately normal? Yes. Law of large counts or large counts condition. So large counts checks for normality. 10% condition means I'm allowed to use my standard deviation formula. That's checking for independence. How do I check large counts? Greater than or equal to 10. And n times 1 minus p is also greater than or equal to 10. Both of those have to be true in order for my sampling distribution to be approximately normal. One thing I want to caution you guys about, I'm almost all the way through grading 7.2 homework, so if you haven't seen your grade yet, it's on its way. Some people are saying the sampling distribution is normal. You always want to shy away from that because you're saying it is exactly or precisely normal. Chances are we do not have an exactly normal distribution, but we have an approximately normal distribution. And so we're allowed to use the normal distribution to approximate that probability. So please, please, please make sure you stick in like approximately at the beginning or APPROX. Abbreviate that you're not saying that it's strictly normal. That it's going to be one of those other places that they'll look for a sticking point. That's going to be the difference between like a 3 and a 4. It seems silly, but it's a very important concept. What about over here when I have two populations? Law of large counts for both, yes. So we would have to do N1 P1 greater than or equal to 10, N1 1 minus P1 greater than or equal to 10, and we have to do the exact same thing with our other population, N2 P2 greater than or equal to 10, N2 1 minus P2 greater than or equal to 10. Z-score formula. How do I calculate that here? I've got Z equals Now my sample proportion, p hat, minus what? Minus p, my true population proportion, divided by standard deviation, which in this case we calculate as the square root of p times 1 minus p over n. So one thing that's true, every time I'm calculating a z-score, we have different letters to talk about each time, but notice right here, we have my observed minus the true divided by the standard deviation. Does that make sense? Very long and complicated formula for the other one, for my z-score. I have to subtract those observed sample proportions. So I do the difference between P1 hat and P2 hat minus the difference in true proportions, P1 minus P2. So again, we have observed minus true divided by our standard deviation. Long, complicated formula for our standard deviation. We've got a big old square root sign. P1 times 1 minus P1 over N1 plus P2 times 1 minus P2 over N2. Standard deviation. Backside of this goes through the exact same ideas, only for the mean. Most of this is straight up the same, except we're using X bar instead of P. What I do want to look at, though, that is slightly different. When is the sampling distribution approximately normal? What did you say? Yes. One of two conditions has to be met. Either the population distribution is normal or my central limit theorem applies. Population distribution is approximately normal. Or n is greater than or equal to 30 so the central limit theorem applies. How would that change with two populations? Both of them have to meet one of those two criteria at the very least. Both of them would have to meet one of those two criteria. All right. 7.3 homework is due tonight. I'm going to go ahead and pass out your review for the test on Friday. My plan right now is that tomorrow in class, we're going to do a free response question. Thank you. 7.2 homeworks, I should be finished up grading today, and you should see those going to Skyward. Remember, you can't resubmit those. If you get a 70% or higher on the test, then any homeworks that you have submitted will go up to 100%. So you'll get full points if you get a 70% or higher on the test. You can always resubmit for more points, so you can keep trying and trying and trying until you get 100%. There should be no reason why anybody is barred from getting 100% on the homework. Do you guys have any questions for me? Yes.